In example 1, we want to construct a price-demand function given two XY coordinate pairs. We're told that a store recently sold a particular item for $13.35. At that price, they sold an average of 30 items per day. When they raised the price to $16.40, sales dropped to an average of 13 items per day. Assume the relationship between price P and demand X is linear. That's an important piece of information because it's telling us that we're going to construct an equation of the form y equals mx plus b, a straight line equation through these 2 points. Then we're told in part A to use Symbolab to find the price-demand equation with demand as the independent variable. That's also a key piece of information because what it's going to tell us is that we're going to set up our xy coordinate pairs in the form of x, so whichever variable comes first is the independent variable, comma p. So in place of y, we're going to be using that price point p. To construct this straight line equation, we'll flip over to Symbolab.com. When I click on the entry field, it's going to pop up this math palette, which we'll use more later in the semester, but for now, we just need to type in the command line through and then enter our two coordinate pairs in the form x comma p. So our first pair was 30 comma 13.35 and our second pair was 13 comma 16.4. Once we have those pairs entered and we've paid close attention to make sure that we have them in that x comma p form, we can click go or press enter to generate that straight line equation. We'll typically round values to about 4 decimal places. And while we were given that output in y equals mx plus b form, it's up to us to know that we should actually rewrite this as p of x, since p is our dependent variable, is going to be equal to negative 0.1794x plus 18.7324. And that's our price demand function with demand as the independent variable. Now in part B, we want to do the same thing, but with price as the independent variable. What changes here is the order of our coordinate pairs. Now those will be in the form p comma x. In order to edit what we've got going on, depending on the type of technology you're using, there's different ways. You can click back on that entry box. Since I'm on a tablet, I click this little pencil, and then I get back to an editable field. What we need to do is delete these points that we entered in, and now re-enter them by flipping that order. Because now we want coordinate pairs of the form p comma x. And again, we'll generate that y equals mx plus b equation. But we want to reframe that in the context of our two variables that we're using. So we'll write this as x of p is equal to negative 5.5738 p plus 104.4098. Generally, for problems that we work, applied problems, we'll want this equation that we came up with in part A, because we use that to generate our revenue function. But as we'll see in part C and D, both versions of this equation, we're using the same information, both versions of that price demand equation can have uses. In part C, we want to use the appropriate equation to find the daily demand if the price is changed to $12.30. In this case, we're given a value for lowercase p, the price. We want to find out what the corresponding x value would be. So that tells us we want to use that second function and evaluate x of 12.3. To do that, we can switch back to Symbolab. And to evaluate an expression at a given value, we can enter negative 5.5378p plus 104.4098 for P is equal to 12.3. So we're just giving it the expression that we want to evaluate and telling it the value that we want to substitute in for that variable. And we get, in this case, 35.85206. But since x is number of units, that has to be a whole number value. So we'll round this to about 36 units. Then in part D, we want to use the appropriate equation to find the price they should charge to sell 69 items per day. Now we're given a value for x, and we want to generate the value for lowercase p. So we'll evaluate p of 69. Going back to Symbolab, now we'll type in the other expression that we came up with, negative 0.1794x plus 18.7324. And we want to evaluate that for x is equal to 69. And we get 6.3538. Since now we're talking about money, P is a price point, we should know to intuitively round that to 2 decimal places. So the price point that would generate our sales goal would be $6.35.